Thank you for coming to my session. I am Shin Tanimoto from microservices Japan. Today I will give you a talk about let's visualize your Spring Boot application about the visualization using Elasticsearch or Spring Cloud Sleuth and Zipkin. Okay, I will introduce myself. I am Shin Tanimoto. I'm an engineer of AgroQuest technology in Japan. I'm a board member of Japan Java User Group. It is called JJUG, JJAG. I am a system architect, and I am a troubleshooter. And now my current interest is microservices and Elasticsearch. Actually, we are selling Elasticsearch. And my team is Mystic. How many of you are Team Mystic member? No one. Only one. Okay, I will give you a talk about Pokemon later. Then my Twitter account is @maxLT, and my Facebook is Shin Tanimoto. Please follow me if you like it. And before starting my session, I want to ask you to, if you have any question, ask me by Twitter or Sleuth. And Sleuth's event code is 5463, and Twitter hashtag is S1P _ VIS. I'm going to answer the questions after my session. Okay, let's begin. It is said that seeing is believing. But engineers don't dare to believe this idiom. Some think seeing deceiving or why so yeah, seeing deceiving or seeing persuading or something. Then why do I say visualizing is important? Because you can't even believe if you see nothing, or you cannot persuade someone if you show nothing. So in the presentation, you need presentation slides. When your boss or manager asks, so is your system work well, or is there any performance shortage or excess amount of instances, or is there, in the first place, does the system contribute to our business? How will you answer the questions without visualization? Will you just open your web browser and access to your system and say everything is fine, the system works well, or something? I don't think so. Or I understand that you will download the server access log and read them all and to confirm the system works well. I don't believe it. Yeah, that's why you visualize your system. System performance or system health. You can explain the system health by visualizing the server status. And there is one more benefit when you visualize your system. That is insights. You can get insights from your visualization. For example, these are the famous diagrams called the Death Star. You cannot see which service called which service, but it is enough. You just know that, oh, it's complicated more than imagination. That is insight. Or if you visualize the server access logs by some means, you might get an insight of something to do with the business. This another reason is to visualize your system, right? Then let's move on to the main subject. This is the start line of my session. Here's a table of contents. I'll explain about the tools first, and then ask 4 questions. Are your server working well? Are your services enough comfortable? How do your microservice look like? And do your service contribute to your business? Another question is it possible to talk about all of the topics in less than 30 minutes? Okay, let's go. Tools. I will introduce 3 tools in this session. One is AWS CloudWatch for monitoring and alerting. And second one is Elasticsearch, Logstash, Kibana bits for monitoring and visualizing logs. And third one is Spring Cloud Sleuth and Zipkin. That is the main topic of this session. So this is for you, I will use for visualizing microservices. Okay. Do you know AWS CloudWatch? Is there anyone don't know CloudWatch? Everyone knows? Google it. If you don't know, it is okay. It is just a kind of monitoring tool. This is the built-in monitoring services for AWS. The custom metrics can, not only the built-in matrices, but also custom metrics can be collected by AWS CLI or AWS SDK on each server, running on each server. And logs can be collected, also logs can be collected by AWS Logs agent. That is the agent to collect logs, to send the logs to the CloudWatch server. And Datadog can be alternative. How many of you are using Datadog? A few. And how many of you are using CloudWatch? Only a few. Okay, I see. And this second tool is Elasticsearch. Elasticsearch, Logstash, Kibana bits. This is a Kibana dashboard. Do you know Elasticsearch? How many of, almost all of you know Elasticsearch. Yeah, Elasticsearch is a full text search engine. And the Logstash is a data collector and data processor and also data sender to the data shipper to the Elasticsearch. And the Kibana is a visualization platform for Elasticsearch. And the bits is a newcomer. That is a data shipper written in Golang. And this stack is so-called ELK stack or elk stack. Elk is like this animal. But it is a little older name. So I know most of people call their elk stack, but because this is Elasticsearch, Logstash, Kibana. But there is newcomers bits. So how we can call them? Elk B? Elk B? The B with elk face? No way. So now we can call them Elastic Stack. This is the official name. I guess Elastic people don't care about the Googleability, but the official name is Elastic Stack. And third one is Spring Cloud Sleuth and Zipkin. Spring Cloud Sleuth is a distributed tracing system solution. It puts the correlation ID, which is a unique request ID, commonly used in microservices to process the request. The trace ID is transmitted through the HTTP request header or RabbitMQ header or some kind of message headers, and all of the microservices to process the request knows the same correlation ID. And the Sleuth also embeds the IDs into the logs using SLF4J MDC. MDC is mapped to diagnostics context. Okay, I forgot the name sometimes. So when you collect logs from several servers, you can find the log lines which are related to the request by the trace ID using the correlation ID. And also you can send trace data to Zipkin or Spring Cloud Sleuth stream. I will explain it later. On the other hand, Zipkin is a distributed tracing system server. I think I can say that Spring Cloud Sleuth is a data collector or a data collection agent running in the microservices. And Zipkin is a server which collects data from Spring Cloud Sleuth. Okay, do you have any question? If you have, ask me Twitter or Slido. Okay, so let's move on. Are your services working well? How do you know? So first of all, you should monitor your servers, CPU usages, memories, and disk spaces. And also, you should monitor the service processes. The process is working or stopped, or the health check via HTTP call or something. And put them on the same dashboard. Putting them on the same dashboard is important to get to know the server status and services, all of the services. And also, you should create alert notification of them. Dashboard is like that. Actually, this is my production environment dashboard, so I masked some names. I masked some names. There are CPU usages and CPU credit balance, and disk space available, disk space usage, memory availability, and process status is. Why do I have to do that? One reason is to see if servers are working well now, just now. And second reason is to see if servers were working well in the past. You should notice if server down and recover last night or sometime in the past. And third reason is to see if servers will be working well in the near future. If the memory usage are increasing or disk availability spaces are decreasing, you must increase them. And to tell the truth, I sometimes didn't care about them. And my server was down in production environment several times. And how to do? I believe you already know to set up monitoring tools. It's very common sense or it's very famous. But do you know top bit of Elasticsearch? Do you know top bit? Only one? OK, I will show you the top bit. Top bit is a data shipper for the Elasticsearch. I will use this mirror display. Really? I forget something. OK, this was the top bit. This is a metric bit now. This is Elastic version 5 alpha version. So top bit is now in the part of the metric bit, but the function is the same. There is a system loads or CPU usages, memory usages, or disk spaces, or something like that. So you can get system status or process status using top bit. Top bit is written in Go and easy to set up. Just run the process, and it will collect data and ship to the Elasticsearch. It's very easy to set up, so I want you to use it. OK, let's go back to the slides. Next question is, are your services enough comfortable? What to do? So first of all, you should monitor the web access. Web access means you should monitor the public API access. So the access count or response time per public API, and response codes, response status codes. All of them are 200 or 500, 400 or something. And monitor the data source, query count, and query response time. This is the image of the data monitoring. The first line is the average of response time per API, such only. There is high peak in the past, but ordinarily it's the column. And the second line is the average of response time per API. That includes all APIs. There are also another days, there is a high peak. But most of the time, it is safe. And the bottom line is the access count per API. These charts notice me the server status or process status and user comfortability. Why do this? To see if the visitors feel comfortable or get annoyed. So how to do? If you use ELB or just use if you use ELB, just use ELB monitoring of the AWS CloudWatch. If you want to know about per API status, collect access logs using Logstash or FileBeat and forward them to Elasticsearch and visualize them on Kibana. Then do you know PacketBeat? PacketBeat is another data shipper written in Go. Like Wireshark or TCP dump, it captures the network packets and analyzes them to obtain data. This is a screenshot of PacketBeat. It shows SQL calls or SQL response time or low SQLs. It is masked. So you don't have to install some data source monitoring tool. You just install the PacketBeat on your microservices. So the microservices use the network to access the data source. So the PacketBeat captures the network packet to create these metrics. Also, it is easy to set up. The next one is the main topic. How do your microservices look like? What do you do? Trace microservices request by Spring Cloud Sleuth and send trace data to Zipkin and visualize them. Why do this? I do this to get a grasp of your system looks like. And when modifying some microservices, you should confirm the influence range. And also, you can find the unused service. Then next, how to do. So go to Spring Initializer website and find Sleuth and Zipkin. And Sleuth dependencies, add Sleuth dependencies to your microservices. And create Zipkin server using Zipkin dependencies. So I know when you start something, it is good thing to go to Spring Initializer. But when you search Sleuth in the Spring Initializer, there are 4 Sleuth things, including 2 Zipkin something. And when you search Zipkin on this site, you will get another 2 Zipkin something. Okay, I will summarize them into the one table. Sleuth, the dependency name Sleuth is Spring Cloud Starter Sleuth, and Sleuth stream is Spring Cloud Sleuth stream, and Zipkin client is Spring Cloud Starter Zipkin. Zipkin stream is Spring Cloud Sleuth Zipkin stream. It's hard to understand them. So I will explain them from the use case. To start simply, you have several microservices, and you want to ship the trace data to Zipkin server via HTTP. The microservices should have the dependency to Zipkin client. The artifact ID is Spring Cloud Starter Zipkin. It collects the data from the microservices and ships it to Zipkin. And on the other side, server side, Zipkin UI is Zipkin auto configure UI is this Zipkin UI server. And Zipkin server, that is the storage, like a storage or search engine, is a Zipkin server. And if you want to use RabbitMQ or Kafka in the middle buffer, you can use Spring Cloud Stream something. As the number of microservices increases and they send lots of trace data to Zipkin, so Zipkin server will not be able to process them, so overspec. Then to prevent the Zipkin server crash, you should use RabbitMQ or Kafka as a middle buffer. And even if Zipkin server is shut down or crashed or stopped, RabbitMQ can store the trace data from the microservices. And when Zipkin server wake up, Zipkin server will get the trace data from RabbitMQ. If you want to create this environment, these are the answers. On the microservices side, there you have to add the dependency through stream and stream rabbit. Through stream is artifact Spring Cloud through stream. And Spring Rabbit is Spring Cloud Starter Stream Rabbit. On the other hand, the server side, Zipkin UI, and Zipkin Stream, Spring Cloud through Zipkin Stream. And Spring Cloud Starter Stream Rabbit is also needed. You can substitute Spring Cloud Stream Binder Rabbit for the Spring Cloud Starter Stream Rabbit. It's enough. I've never tried, but I think Kafka can be used for RabbitMQ. So with Spring Cloud Stream Binder Kafka. And when you start the microservices or Zipkin server, RabbitMQ's exchange and queues are automatically created. So all the trace data is shipped to the exchange named Sleuth. And Zipkin server gets the trace data from the queue named Sleuth. That is summarized, Sleuth and Zipkin dependencies. If you use the HTTP, Zipkin client is necessary for the client side, and Zipkin UI and the Zipkin server is necessary for the server side. And when you use AMQP, Sleuth stream and Sleuth stream is necessary for the client side, and Zipkin stream and Zipkin UI is necessary for the server side, and Stream Rabbit is necessary for both. Then, what is this? What is the Sleuth? Spring Cloud Starter Sleuth. This is just add the trace and span IDs to the logs. It doesn't have the ability to ship the data. Let's check the source code. This is a Zipkin server application to use HTTP. You just add the annotation enable Zipkin server and run this application to run the Zipkin server. And if you want to use the RabbitMQ or Kafka in the middle buffer, like stream, you just add this annotation enable Zipkin stream server. And on the other hand, the client side, no source code modification is necessary for the microservices. OK, let's take a brief demo. I just have 5 minutes. Here is a sample application written in Spring and Spring Cloud. Like an e-commerce site example. Let's run this test. This test calls the show catalog. So access to get the data from the catalog and and put the items into the cart, and get the cart again, and order, checkout. When I run this test, just finish. And find them in Zipkin. Store service. Store service is the front, like BFF. Find traces. You can see the. You can find the bottleneck or some response time bottlenecks from this chart. And you can also find the dependencies of the services. No. Store service calls the stock service and the item service, and when I check out, store service calls the order service, and order service calls the stock service, cart service, payment service. I have no time. Note that Spring Cloud Sleuth does not support Rabbit template. This is a class including the Spring Boot Starter MQP. Spring Cloud Sleuth supports Streamrabbit, Spring Cloud Starter Streamrabbit. So if you are using MQP or if you are using Rabbit MQ, you shouldn't use the Spring Boot Starter MQP. You should use Spring Cloud Starter Streamrabbit. Okay, I have no time more, so there is another chapter, but I will give the slide after this session. So last one is I committed the sample code in the GitHub, and all the clip arts are downloaded by Elasticsearch in Japan. So thank you very much for coming to my session. Thank you very much. If you have any question, come after this session. Thank you.